So in this situation, we're going to look at a probability tree diagram or a weighted tree diagram. Basically, it's a tree diagram that shows the probability of each outcome at each step. We use this when we don't have equally likely outcomes. So, for example, a biased coin is flipped 3 times. It is twice as likely for a head to land compared to a tail. Use a tree diagram to show all possible outcomes. So, this is a fairly important sentence. It is twice as likely for a head to land compared to a tail. That means for every 3 flips, I would get 2 heads and 1 tail. So for every 3 flips, I would get 2 heads and 1 tail because it's twice as likely to get a head. So let's have a little look. In our first step, just as before, we have 2 possible outcomes. We have a head. You have to excuse this, it's being a little bit temperamental, and a tail. Okay, but now we're going to add some weights. The chance of getting a head is 2 times a tail, or if it were 3 flips, we would have 2 out of 3. And the chance of getting a tail is 1 out of 3. At the second step, we have 2 possible outcomes. We have a head and a tail. We have a head and a tail. Okay, and once again, the chance of getting a head is 2/3. The chance of getting a tail is 1/3. And that repeats on every branch. And then our third throw, we have a head, a tail, a head, a tail, a head, a tail, a head, and a tail. And once again, the chance of getting a head is 2/3, tail is 1/3. And you can see I'm running out of a bit of space with my stylus here, but that would repeat 2/3, 2/3, 2/3 on all the heads, and 1/3, 1/3, 1/3 on all the tails. Now, when it comes to writing the sample space, so a list of all the possible outcomes is much the same. Head, head, head. Head, head, tail. Head, tail, head. Head, tail, tail. Head, tail, head, head. Tail, head, tail. Tail, tail, head. And tail, tail, tail. So the list of the sample space is the same. However, if we wanted the probability of 3 heads, probability of 3 heads, I would have to look at what happens at each step. The first chance of getting a head is 2/3 times the next one, 2/3 times the next one, 2/3, which altogether is 2 times 2 times 2 is 8 over 3 times 3 times 3, which is 27. And if you compared this to the previous one where it was unweighted, the chance of getting 3 heads was 1 out of 8. So let's have a look at the probability of exactly 2 heads. We're looking at the situation here, here, and here. Now for each one of those probabilities, I have to work my way down the tree. So to get head, head, tail, I have to go head, probability of head is 2/3, probability of another head is 2/3, and the probability of a tail is 1/3. So 2/3 times 2/3 times 1/3. 2/3 times 2/3 times 1/3, which is going to be 4/27 plus. Now I have to find the probability of getting head, tail, head. Head, tail, head. Probability of getting head, tail, head. I have to follow the tree diagram. Head, tail, head. And that will be 2/3 times 1/3 times 2/3, which again is 4/27. And to find the very last one, tail, tail, head, I have to follow the tree diagram. Tail, head, head. So 1/3, 2/3, 2/3, which, as you might have guessed, is also 4/27. So altogether, 4 plus 4 plus 4 is 12 out of 27. So you'll notice again that this is different. So the probability of getting exactly 2 heads on this weighted tree diagram is 12 out of 27, even though if I just looked at the outcomes, there's 3 out of 8 outcomes. And that's because the outcomes are not equally likely, and I have to look at each individual chance at each individual step to work it out.